Notice in these next couple of examples and in some other examples you'll see on this page that the y is squared. So there are some things you can do to make these easy to solve. It turns out that the quadratic formula works no matter what variable is in place. So when we have y equals ax squared plus bx plus c, then x equals any x value that solves the equation when y equals 0 is equal to negative b times the square root of b squared minus 4ac over 2a. And it turns out if you reverse these variables, it doesn't matter which variable is in there. You can make this equal to any variable you want. We could put r or L or M in place of the variable with A and B, and it would still be solved with the quadratic formula. So x equals y squared minus 5 is in standard form already because we have x equals y squared minus 5, and we can rewrite that as x equals y squared plus 0x minus 5, or 0y minus 5. And this is an ax squared plus bx plus c, which means that we would have y equals 0 plus or minus the square root of 0 squared minus 4 times 1 times negative 5 is a equals 1 equals 0 equals negative 5 all over 2 times 1. And now we simplify. We have positive or negative square root of square root of 20 over 2, which is equal to positive or negative 5 root 2 over 2. And that is equal to positive 5 times root 2 over 2, all of this over 2, 3.536, and negative 3.536, 3.536. And that would be around, this is 2, that would be around here and here. And then we can see from the negative 5 at the end that it is in the C position instead of being the y-intercept. It is now the x-intercept. The x-intercept is at negative 5, and that also ends up being the vertex for this sideways parabola that's graphed like that. We're very careful about how we graph our parabola, and it's not a V, it has a curve. And then we graph the linear equation, which is x equals y, and that's a linear equation that cuts through the very middle of the graph with these two solutions. I graphed it on the wrong axis. I graphed my parabola on the wrong coordinate plane. So this comes out like this. This comes out like that. And then we have a more complicated linear equation up here. So negative x plus 2y equals 12. And so we can see that negative x plus 2y, we would solve for y, so plus x, and divide by 2. So y equals 1/2 x plus 6, positive 6, run 2 up 1, make as many points as I can, connect the lines, and then you tell me how many solutions they have. For these equations, this equation right here that is graphed a couple, or that has a couple of quadratics, I would graph this in Desmos. But you tell me what kind of equations, or where are the solutions to number 3. This is 3 and 4, 5 and 6.